Hello, I'm Ms. Hanley, and today we're going to talk about compound inequalities. So compound inequalities are a way to combine two different inequalities. Say if we need to put constraints or a parameter on something, and we want a number that's in between two different things, two different specified numbers. We need a value that is greater than one thing and less than another, something like that. And there are two different kinds of compound inequalities. There's an OR, where you can say I have one thing or the other, or you can have an AND compound inequality, where you can say I want a number to be this and this at the same time. So for compound inequalities with an OR, which is what we're going to start with, you want something that can be true, and it's going to be true either or. So you can have information that satisfies one side and also satisfies another, but they don't have to overlap. They don't have to intermingle at all. And let's look at our first example here. We have 2x plus 5, and I'm actually going to change this to be less than 11. Or we have x plus 1 is less than 7. So there are two situations. Oh, sorry, greater than 7. I have everything backwards. So 2x plus 5 is less than 11, or x plus 1 is greater than 7. Whenever you have two separate inequalities with the word or, you know it's an or inequality. And inequalities can sometimes be combined. So if I look at the first one, we just want to solve both of these separately, just like you would a regular inequality, and then we're going to combine them and onto one number line. So my first inequality says 2x plus 5 is less than 11. So I'm going to start by isolating the variable and subtracting 5. And we end with 2x is less than 6. Dividing is my second step, so x is less than 3. Connecting with the word or still. And the reason that I am solving this way and I didn't flip my sign, we didn't have to divide by a negative here, so there's no sign flipping. Everything is okay. On the right-hand side, we have x plus 1 greater than 7. So I'm going to take away 1 from both sides, and we end up with x greater than 6. All right, so if you recall from set builder notation, we start with our set brace, and this becomes my answer here. So I'm looking for a number that's less than 3 or is greater than 6. So I'm going to say I have all real numbers x such that x is less than 3 or x is greater than 6. With compound inequalities, and if it's an or, you're just going to write the word or in between, nothing else. Now let's go down and graph it. And the trick with ORs is they'll usually go in opposite directions. Now, they might be going in opposite directions but overlap, and that's a situation you'll get into in a minute. That's all real numbers. But for now, let's look at one where it goes opposite. So with graphing, you want at least 3 numbers on your number line. 0 is usually a good one, 3 and 6. And then remember, if it's just a less than or a greater than, it's an open circle. If it's less than or equal to or greater than or equal to, it's a closed circle. And I'm going to circle 3. And I'm just going to write above my number line for right now. I want everything less than 3. If it's greater than 6, I want everything greater than 6. And those aren't overlapping, so I know I have either or, which means I can have a number that's less than 3, which could be anything that way, or a number that's greater than 6. So lots of options, right? So or is called, it's considered a union of numbers, where you can have one or the other. Both statements don't have to be true at the same time. Because obviously there's no number that's less than 3, like let's say 0, and greater than 6 at the same time. Alright, so the second one is with an AND. So here you have your two statements, 2x minus 6 greater than negative 8, and x plus 4 is less than 9. So by solving separately here, adding 6. So 2x is greater than negative 2. Here I'm dividing by 2. Since I didn't divide by a negative though, I'm still not switching my sign. And so x is greater than negative 1. Bring down the word and then the second part, we're taking away 4. So x is less than 5. Now with an and, you want these things to be true at the same time. So think about numbers that are between negative 1 and 5, like 0, 1, 2, 3, 4, or any of those fractions or decimals in between. 1.5, 1.879, 3.56, 4 2/3. Anything like that is going to fall in this category. Now there's no way to list all those numbers because there's an infinite amount. However, we can say that there's a range. All right, so we're going to write these in step builder notation. So I have all real numbers x, and you can write and inequalities as 2 separate pieces. What I would prefer is to write them as one string so that we can clearly see the range. So when you do that, we want to talk about flipping our inequalities. We used to do this when we didn't have a variable on the left. Now we're going to try and flip it backwards. So if I flip x is greater than negative 1, it becomes negative 1 is less than x. Now I'm going to start my inequality down below with x is less than 5. And then on the other side of that, I'm going to break down this piece here. So negative 1 is less than x. You always want your inequality signs to be pointing the same direction. Usually we try and make it so that the lower number's on the left and the higher number's on the right, but you're not wrong if you have it going the opposite direction. Now let's check out what that looks like on a number line. So here, we need the numbers negative 1, and then probably 0, 1, 2, 3, 4, 5. You could put other numbers on there if you want to. I need at least 3, okay? Both open circles. This time I have all my numbers that are greater than negative 1, so shading to the right. And then I have numbers that are less than 5, so shading to the left. We want numbers that satisfy that at the same time. So numbers that are greater than negative 1 and less than 5 are where those two shadings overlap. So everything in between is what I want actually shaded. And then we can erase our arrows. You don't actually have to draw the arrows, but they just help me visualize what I need. And that's all there is to compound inequalities.